Welcome to Math with Mrs. Bibb. Today I am going to discuss how to solve radical equations. Listed you will see the steps for solving radical equations. These steps look very similar to solving an absolute value equation. The first thing you're going to do is get the radical alone. Check the number on the other side of the equal sign. If the root is even, the number must be positive. If it is not, the answer is no solution. If the root is odd, it does not matter. If that number on the other side of the equal sign is negative, you just carry on. Step 3, raise both sides to the same power as the root. This will eliminate the radical. And then step 4, solve for your variable. Here's my first equation. You'll notice that the square root of x is not alone. Plus 2 is with that square root of x. So I am going to subtract 2 to get the square root of x alone. 10 minus 2 is 8. Now my radical is alone. I do have an even root. Remember to find what kind of root you have. You look here. This is square root, so this is an even root. So then I check my number that's on the other side of the equal sign. It is positive, so I can continue on to the next step. I'm going to raise both sides to the second power. X will equal 64. Now, of course, hopefully you'll think about this. You wouldn't necessarily have to solve it this way. You could think reasonably, what number can I take the square root of and get 8? And hopefully in your mind you said 64. The square root of 64 is 8. So that is one way to think about how to solve these problems. For my next one, I need to get the square root of x alone. I need to subtract 3 first. That will eliminate the 3. I need to keep the negative 1 times the square root of x because I just need to keep that. 0 minus 3 is negative 3. Then my square root of x is not alone, so I need to divide by the square root of negative 1. That would make a positive square root of x. And x will equal 3. Now my radical is alone. It is an even root, and the number on the right is positive, so I will raise both sides to the second power. X will equal 9. My next example, the square root of y is not alone, so I will subtract 15. The square root of y equals 7. I will raise both sides to the second power because 7 is positive. It is an even root. So y will equal 49. The next one, I have several things that's with my square root. So I need to subtract the 3 first. You always get rid of your addition and subtraction first. 19 minus 3 is 16. Then I need to divide by 4. The square root of x plus 2 equals 4. I do have an even root. The number on the right is positive, so I'm going to raise both sides to the second power. The square root of x plus 2 squared is just x plus 2, and that equals 16. And now I subtract 2 from both sides to get x alone, so x equals 14. And of course you could substitute this number in. 14 plus 2 is 16. The square root of 16 is 4. 4 times 4 is 16, plus 3 more is 19. So that does work. My next one, the only thing I have with the square root is plus 7. So I'm going to subtract 7. The square root of x plus 4 equals 4. I'm going to raise both sides to the second power. X plus 4 will equal 16. And then subtract 4. X will equal 12. My next problem, I need to get rid of this 6. Now I want you to be very careful because students will automatically add these together and make this 9. but this 3 is being multiplied, this 6 is being added. So I need to get rid of the 6 first by performing the opposite operation of subtraction, and that would give me 9 equals 3 times the square root of 3w minus 9. Then I need to get rid of multiplying by 3 by dividing by 3. So 3 will equal the square root of 3w minus 9. I do have an even root. My number on the other side of the equal sign is positive, so I will raise both sides to the second power to eliminate the radical symbol. So the square root of 3w minus 9 squared is 3w minus 9. I will add 9 to both sides. 18 equals 3w. Divide by 3. W is 6. Moving on to the next example. This is very strange. I have a radical on the left side of the equal sign and a radical on the right side of the equal sign. So that means I can't do any of those beginning steps. I just have to raise both sides to the second power. That will eliminate the radical. 3x plus 1 equals 4x minus 7. Then I will subtract 3x. 1 equals x minus 7. I will add 7. So 8 equals x. Now I need to check to make sure this is correct and that it satisfies the radical, because whatever value that I substitute in for x must yield a positive number under the square root, or else it wouldn't be possible. So if I put 8, 3 times 8 is 24, 24 plus 1 is 25. Square root of 25 is 5. 4 times 8 is 32. 32 minus 7 is 25, and the square root of 25 is 25. So that means that 8 is the answer to that question. Same thing for the next one. I do not have anything over here with the radical or here with the radical. Even if I did, I would have to square those things. That's something definitely later on in Algebra 2. For example, if you had this, you would need to raise both sides to the second power, which means this would be the square root of n plus 1 times the square root of n plus 1, which means you have to distribute and all those lovely things. So when you have this type of circumstance, you actually end up going through those steps that I have written twice. In this circumstance that I have, though, I do not need to go through those steps twice. I just need to raise both sides to the second power. N will equal 5n minus 1. I will subtract 5n. Negative 4n equals negative 1. I will divide by negative 4. N is positive 1/4. So the square root of 1/4 is 1/2. 5 times 1/4 is 5/4. 5/4 minus 4/4 is 1/4, and the square root of 1/4 is 1/2. So that does satisfy the radicals in that problem. Moving on to the next one. Now, if you notice, I actually have a different root. This is cube root. So I'm still going to follow the directions the same. And you can see here I whited out the radicand's symbol here. So here it stops at this point, and I need to get rid of the minus 4. So I'm going to add 4 to both sides. The cube root of y equals 5. And I have an odd root, so it doesn't matter if the number on the other side is positive. And now I raise both sides to the third power. So the cube root of y cubed is y, and then 5 cubed is 125. And the last example, again, I have cube root, so I'm going to get that cube root alone by subtracting 2. So I have the cube root of 3n plus 7 equals 10. I'm going to raise both sides to the third power. The cube root of 3n plus 7 cubed is 3n plus 7. 10 cubed is 1,000. I'm going to subtract 7. 3n equals 993. 3, divide by 3, n will equal 331, I do believe. So hopefully now you understand a little bit how to solve a radical equation. Whatever this root is, it could be fourth root, there could be a 4 here, there could be a 5, that's fifth root, sixth root. Whatever that root is, you raise both sides to that power, and that actually makes your radicand disappear. So that's how you solve a radical equation. Have a wonderful day.